Hi, and right now we get back to the second part of the strength of material. So the focus is for uniaxial compressive stress. And based on this statement, we have different types of. If we have different types of rock, it will give different types of strength. So the strength that we discuss right now is tensile strength, compressive strength, and also shear strength. Okay, what are the factors affecting? You can read the second statement here. The strength of a rock material determined in the uniaxial compression or point load test is dependent on the moisture content of the specimen and isotropy and the test procedure adopted. So when you do the testing, you need to report all of this. It is possible for all of you to record the initial moisture content of the specimen, and then you record how you place the specimen on the machine, and of course you need to detail out what are the test procedure you are adopted during the testing period. Okay, we also need to use simpler index in the field, meaning that when you go on site or you go to the field, okay, you need to use this simpler index to verify the data. And what are the tests that you can do on site? You can actually use point load test, and of course you can use Smith hammer or rebound hammer, and these are the tests that commonly used on site. Okay, these are also the factor affecting the test. The size and shape of lumps definitely will affect the value. Strength of operator, meaning that who conduct the test, whether he is strong or he is not. So this also will affect the value of strength. Weight of hammer and surface on which lump rests affect the assessment to the strength. Okay, these are the common mechanic properties. We have a lot more of properties that we can discuss, but in this segment, what you need to do is what you need to know is all of these common mechanic properties. We have done the discussion about density. Density basically is mass over volume of your specimen. And we need to discuss under elastic properties. This is test that you can do under uniaxial compressive stress. And when you do the uniaxial compressive test, we get the relationship, and from the relationship we can create a lot more of equation for you to understand the mechanic properties of the sample. Okay, the first one, you do the uniaxial rock mechanic test, and you get the relationship. You can draw the graph, and from the graph you can get the information for deformation and strain, and of course the value for elastic modulus and Poisson ratio. Applying Hooke's law to get the linear elastic constitutive relation. And next, when conducting triaxial rock mechanic tests, what the results are: the Mohs circle, the combination of Coulomb shear failure criterion and Mohs circle, and the last one is expressing Coulomb criteria by principal stresses. Okay, this is the table has been mentioned earlier. The rock type is granite, basalt, quartzite, marble, sandstone, and limestone. And T min, T max is actually shear tensile strength minimum and tensile strength maximum. S min, S max is shear strength minimum and maximum. C is compressive stress or compressive strength for minimum and maximum value. So this is just the example of few rock that tabulated in this table, and we can identify a lot of differences, the value for all of these rocks. So next is to understand about uniaxial compression test. To compare with point load and rebound hammer, you already have covered that one in your lab session. For UCT, this is uniaxial compression test. Let's look to the machine first. Okay, we have the top cap. It is round in terms of the shape, and we have the mounted. This is where you will mount your sample. Most of the time you are using cylinder sample or rectangular sample. So if you can see the top of the compressive, this one is cylinder, so it can put on uniform load on the top of your sample. So this is more complicated to compare with your point load test, and all of these are connected to mechanical items and also electrical item. So at the end of the day, when you have compressed your sample and your sample have reached the failure points, it can give the value that you need. So in a UCT, the direction of the load is called the maximum principal direction, and there are no other loads working on other direction. So we have only one direction, which is from vertical direction, or that is what we call as maximum principal direction. Attention should be exercised to the fact that the convention for defining the principal direction and principal stress may be different from earth science and physics. So um, we might define differently from those who are in the field of earth science and also physics. Okay, these are the things that you want to look when you do the triaxial compression test. Okay, what are the difference to compare with UCT? UCT you only apply one direction of stress, but in terms of triaxial compression test, you need three different uh, direction to do the triaxial compression test. In triaxial compression test, the direction of the load is called the maximum principal direction. Okay, this one, the first picture is the maximum principal. And the direction of the confining pressure. Okay, what is the meaning by compressor? Meaning that your sample subjected to all round pressure. The sample fill around the sample we give pressure, and that is what we call as all round pressure, or it also known as minimum principal direction. Attention should be exercised to the fact that the convention for defining the principal direction and principal stress may be different from earth science and physics. In the direction of principal stress, stress 1 and stress 3, there is no shear stress. Okay, so this stress is given to the sample simultaneously, and then afterwards you will see the failure point basically at 45 angle of the failure point. So next is the engineering laboratory test. This is common, uh, meaning that you already covered all of this before this. You have the slate durability test, point load test, and rebound hardness test. So slate durability test, there is a lot of procedure that you need to consider before you do the test, and at the end the at the end of the testing you will get the slate durability index. And this table by Franklin and Chandra is the indicator when you get if you get 95% of slate durability, or you get the value of 25 to 50. So what it is mean? The meaning of it is you must report in your lab. It is to report the lab. Either you report it very high, you report it high, medium, low, or very low. So that's when you do the durability test. You get the final report, and this report will be considered for those who will do the decision making. Okay, this is what you already have seen, and you are the equation given. This is the equation to calculate the slate durability index. So this is how you interpret all the data. Okay, next is point load test. Okay, you also have covered this one. Okay, we have specific equation to calculate the point load index, and this is the equation that you can use to calculate the point load index. And this is one of the example of the point load test apparatus. We are applying pressure, and the pressure is basically from hydraulic pressure. because we need a very high pressure to compress the specimen, and we need to make sure the specimen fail, and we record that value. Okay, the important things during the point load test, we need specific dimension. If you have uh, cylinder types of samples, so you must make sure the length must be more than 0.5 d, or the diameter. So if you need to load it along the core axis, make sure the size is 0.3 width, more than d, the depth of the specimen, more than the width of the specimen. And of course we can test this into the irregular shape, but you must make sure the L must be more than 0.5 d, the depth of the sample. Okay, you can observe this picture, and these are all the suggestion when you want to do the point load test. Okay, next is, okay, the thing that you need to understand when you do the point load test, we basically need to take a photo of the failure, because we want to sketch what is the orientation of the failure. And how you interpret, you need to use this graph. You get the value of is or point load index test. Use the graph, and then interpret from the linear line here, and then get the value of UCS, or in terms of compressive strength in the unit of megapascal. Okay, these are all the example to know the value for point load index. Okay, the material used in the table here, you have tertiary sandstone and claystone, coal, limestone, mudstone, shale, volcanic flow rocks, and also dolomites. Okay, rebound hammer test. This is portable machine or portable apparatus that you can use it on site, or you can use it during the lab session. This one is also have been covered in your lab session. Okay, now we need to understand about rock deformation. Okay, what is deformation? Deformation means change in shape. The deformation is the change of shape and size of material under loading. The elastic deformation is the part of the kind of deformation that can be recoverable. Example, after the load is removed, the material change back to its original shape and size. The part of kind of deformation that cannot be recovered is the plastic or ductile deformation. The property of the material of elastic deformation is called elasticity, while the property of plastic deformation is the plasticity. Okay, this is when you load the force on the top of your sample. During this activity, your sample is basically either shortened or elongate. And during the load, we will record the deformation. After you unload the load, sometimes the sample will come back to its original condition, or original size and shape. In this particular situation, the deformation, we call it as elastic. But if you identify there is a significant change in the sample after you load, that one is considered under plastic deformation or ductile deformation. The property of the material of plastic deformation is called elasticity, while the properties of plastic deformation is the plasticity. Okay, now we learn again about stress and strain. I believe that we already explained this in previous chapter about stress and strain. Stress, the definition of stress is force per unit area. In special case, stress in fluid is called pressure. The stress at given point in all directions are all the same. or we call it as isotropic stress. If you have only one direction of stress, that one is we call as stress. If you have all round pressure or your sample is inside the liquid, that is what we call as pressure. For strain, deformation in a unit length, volume or area. Strength is the change that you can measure. So whatever change when you load the sample with load, you observe there is changes. So you can measure these changes, and this is what we call as strain. Change in shape or size of an object in response to an applied stress. There are three types of strain, which are elastic, ductile, and brittle. Okay, how to describe the three types of strain? For elastic deformation, a temporary change in shape or size that is recovered when the applied stress is removed. The change is only when you apply the load. For the ductile deformation, a permanent change in shape or size that is not recovered when the applied stress is removed. For example, it is flow or bends. In terms of the brittle deformation or rupture, the loss of cohesion of a body under the influence of deforming stress. For example, it is break. Okay, this is the thing that you need to know when you apply load and your sample is actually undergone deformation, and we can uh, gather all the data. At the end of the day, you can draw this graph. The graph is the relationship between stress and also strain. So we have different segment here. If you consider to the graph, the straight line or the linear lines is what we call as elastic limit. Okay, now we have some curve after the elastic limit. So that one is ductile behavior. And towards the end, when you see that graph is dropped down, so that is basically when your sample break. And right now we are calling that failure as a rupture strength. Okay, this is another way for you to look into the graph representing the stress versus strain. Okay, that one is under engineering or mechanical properties of rock. Okay, now when we have known about the strength, when we know about the slate durability, now how we want to classify this, and after the classification, what is how we want to use it in engineering. So there are two ways to classify the intact rock in terms of two parameters using compressive strength alone and use the ratio of E over CO. E is the modulus of elasticity. Yeah? Using compressive strength alone, we can classify the rock into 5 classes. Okay, either A, B, C, D, and E. So if you want to imagine, this is how we grade our rock. Like if you go to the market and then you want to buy eggs, so there are different grade of eggs. So you have A, B, C, and D. Kind of that the similarity of the classification. For rock with very high compressive strength to very low compressive strength. Okay, using the ratio of Young modulus to the compressive strength E versus CO, we can classify the rock into 3 classes, which is high, medium, or low. So by combining the two methods, we may have rock classified as BH, BM, CM, and etc. Okay, let's look into this table. This is engineering classification of intact rock based on compressive strength. So when you do the compressive strength test and then you get the value of strength, let's say you get the value of strength 220. So you know already, referring to the table, this is the grade A or the class A rock. And if you get the strength lower than 25.5, this is basically class E rock. Okay, and then in the table also give the representative of rock. Class A, it is quartzite, diabase, and dense basalt. For class E, you have clay, shale, and rock salts. And for the classification using two different index, which is E versus CO. Okay, and then what you need to know is the value of E and then the value of CO, and do the calculation, and then you get the value. If you get the value of 500, that is class H. If you get the value 200 to 500, that is the medium class, and if you get 200, that is the low. Okay, next is the field measurement apparatus for rock. Rock classification system was proposed in order to formalize an empirical approach of classification for geotechnical engineering work. The rock mass classification were developed for investigation procedure and the most predominant design approach. The rock mass classification is also a system of classification for a systematic planning and documentation of the related ground information. Okay, so you need to know about the criteria. This one is under fracture state. If you have total core recovery, or we call it as TCR, this is the ratio of core recovered, solid or non-intact, to length of the core run. Okay, and then if you get solid core recovery, or SCR, it is the ratio of solid core recovered to length of core run. So you have also the RQD, or rock quality designation, and then you have to know about the fracture index. Okay, rock quality designation, RQD, and the fracture index. Okay, this is how you interpret. If you have RQD 19 to 100%, and number of fracture is 1, the description is excellent. Okay, this is how you want to understand this one. Can you remember that we have done map 3, and during map 3 you need to drill the cross section, and the drilling process is what we call as borehole. So when you do the drilling, you are lowering a casing, and then when you lower the casing, at the same time you will capture the sample inside the earth crust. Next, you will take this sample, and then you will extract from the sampler. You get the original sample from site. So the meaning of recovery, meaning that if you have about 1 meter length of sampler, and then when you extract the sample, you get 1 meter length of sample. That is what we call as 100% recovery. And then you check on the surface of the sample, is there any fracture? If only one fracture, less than one fracture, we are considering the sample is very good condition, and we call it as excellent. Okay, this is what I explained just now. Okay, when you do the borehole with casing, and you drill the earth crust, and you will recover some sample, and if you get 100% recovery, so that is very excellent. But if you see this one, if you have some features or crack, or some deformation on the top of the surface, so that one is not good quality of rock sample. Alright, so that is all to understand about geology, and this is the last part of engineering geology. Thank you.